Hello, in this video I want to talk about a very interesting question that many physicists are working on right now. How can we create the perfect single-photon source? We want to answer the questions: what is a single-photon source and why do we want to build one? Let's start with a thought experiment. Imagine we have a light source, for example a laser. It sends out a beam of light made of many photons. To detect them, we use special counting electronics. And in our ideal thought experiment, these electronics are perfect. They detect every photon instantly and never miss a single one. Now, let's measure for a certain time interval, which we will call t. In this interval, the light source produces an average of 10 photons. But even if the average is 10, the actual number of photons detected in each segment can vary a lot. If we divide our time t into 10 small segments, we might get something like this. In the first two cases, photons sometimes arrive in bunches and sometimes not at all. If you want to know more about it, search for photon bunching and anti-bunching. But let's look at the last case. This is the perfect single-photon source that gives exactly one photon per segment. Never zero, never two. So why do we care so much about this? Let's look at the example from quantum communication. Imagine Alice wants to send Bob a top-secret pancake recipe. Alice encodes information in the polarization of each photon. Photons can point in different directions, and these directions can represent different bits of the recipe. If the photon source is not perfect, for example if there are secretly two photons in each segment, an eavesdropper, let's call her Eve, could steal one photon each time. Bob would still receive one photon and would not notice that someone intercepted the message. But with a perfect single photon source, Alice and Bob know exactly what to expect: one photon per segment. If suddenly one photon is missing, they immediately know that something is wrong and can stop the communication. And this is why single photon sources are so important. They allow secure communication and are key components for future quantum technologies.